What's up, electronics and robotics? Mr. Ashline here. Today we're going to be talking about controlling a servo with a potentiometer, building off of last week's lesson. So this week our task is going to be, we're going to program a servo to move with a potentiometer. When the input of the potentiometer is equal to 0, the output's going to be equal to 0. And then when the input of the potentiometer is equal to 1023, the output is going to be equal to 180. You're also going to have to print the value of the potentiometer and print the value of the servo output during this process. So let's just do some quick review about things like a potentiometer and the map function. So remember, a potentiometer is an analog input. Okay, so when we go to define this in our pin modes, it's going to be an input. When we go to wire it, we're going to use an analog port. We're also going to use the analog read function to be able to read this thing. And also remember, we've talked about this in class, but game controllers like the PlayStation, the Xbox, the Switch, all of these different controllers use an analog potentiometer on the joysticks. Typically, one of the trigger buttons on both sides is also an analog potentiometer used as inputs. Okay, those are all different input devices. So we can use a potentiometer as an input to control the output of our servo, just like you can use your video game controller input to be able to control, the character in the game itself, or whatever it is that you're doing. So remember, the analog input on an Arduino is read with 10 bits of precision. So remember, a bit is a binary digit, either a 0 or a 1. And when we run that through here, that gives us a value of an input between 0 and 1023. Okay, and also if you remember back to last week's lesson, a standard servo uses values between 0 degrees and 180 degrees as its input to control the position of the servo. So we're going to need to correlate the input, which is a much bigger range, a much bigger set of values, and we're going to need to reduce those down in a scaled ratio so that the output is aligned. Okay, so again, when our input reads 0, our output is going to read 0, and when our input reads 1023, our output is going to output 180. So let's review the map function. Okay, so a map function is used to scale two different values together. Okay, like the values that we're trying to scale right now. It consists of 5 arguments, and again, the arguments are the things within the parentheses that are going to output this. Okay, so we have, first of all, our output value, which in this case is going to be whatever value we use to control our servo. Is going to range between 0 and 180. That's going to be set to a map of, and then in our parentheses we have our 5 arguments. So our first argument is our input value, which is going to be the potentiometer. We're going to read the potentiometer, and that's going to equal our input value. Then comma, a low input value, a high input value. Okay, so this is the low value of the potentiometer and the high value of the potentiometer, because those are all our inputs. And then we have our low output value and our high output value. And again, our output in this case is going to be our servo control number. So our low value and our high value. So remember, our input value is our pot value. That's going to range between 0 and 1023. Our low input for our potentiometer is 0, right? That's this number here to here. Our high output value is 1023. Again, that's the high end of our input, so that's the high end value here. Then our low end value of our output is the low end of our servo control, so that's going to be equal to 0, and our high end output is going to be equal to 180. Okay, and the output value is going to range from 0 to 180, right? That's this part here, the output value up here. will range from 0 to 180 and will be a ratio between the defined input and the desired output. So again, if like our input reads 25% of the way between these two numbers, then we're going to read 25% of the way between these two numbers here. If this value is like 50% between these two numbers, then our output will be 50% between these two numbers. That's what I mean by it will be a scaled ratio between them, okay? There's always going to be a percentage. Whatever percentage this is going to output a percentage between those two values there. So once again, this week, this is our task. We need to print the values of our potentiometer, print the values of our servo output, and write a program to control a servo using those pieces. So let's switch over here to last week's assignments. And we will get started here. So I'm going to go back, instead of just starting at servo activity 1, I'm going to go back to all of my activities. And the gear up here, I'm going to say duplicate. All right, so I'm going to just edit my name. I'm going to call this servo activity 2. Okay, so my servo's already wired up. We need to get a potentiometer into the system here. So again, we have our terminal 1, we have our wiper, and we have our terminal 2. Terminal 1 and terminal 2 can either go, one of them needs to go to ground, one of them needs to go to 5 volts. Okay, so I think I'm going to connect this first one up to 5 volts, which I think I can just connect over top of that other one. Terminal 2, we're going to bring to ground. Again, those could be switched, doesn't really matter that much. And then our wiper, again, this is an analog input, so our wiper is going to go to one of the analog inputs here. And we'll just kind of clean that up quick. All right. So we have a potentiometer, that's all wired up. We have our servo, that's all wired up. So our servo, again, is on digital pin 7, while our potentiometer is on analog pin 0. We're going to open up our code here. Again, I'm going to change this to say 2. I'm still including my servo.h. I still have a servo that's named example. But we're going to get rid of all of this up here. Maybe I'll leave the attach, actually. We'll get rid of most of this up here, but we will leave the attach. So remember, example.attach or .attach is going to take whatever your servo name is. In my case, it's example. And it's going to attach it to whatever pin number this is here. So that's connecting and defining the fact that the servo named example is connected to pin 7. We're going to create a pin mode for our pot, and we're going to say that this is an input. But before I can even use that, I need to also define the name potentiometer. Okay, so integer pot is going to be set to input A0, analog 0. Okay, and because we need to print some information, the last thing we need to add to our void setup here is serial.begin 9600. Okay. So down here in our void loop, the first thing we need to do is we need to read our potentiometer value. So let's create a new integer up top here. Let's say integer, and let's call this pot value. Okay, so this is blank for right now. Okay, we're going to populate this whatever the value of that potentiometer is equal to. So down here we can say pot value is set to an analog read of your pot, okay, which is going to say whatever the potentiometer is going to read between 0 and 1023 at that exact moment, that's going to get assigned to this pot value box. we can serial.print, and I think I'm going to start off by labeling some things. Let's label this input value, we'll say. Okay, so my input value is going to be equal to my pot value. So if we start our simulation at this point here and we check our serial monitor, notice that this thing is floating because we're not doing anything with it, but we have 1023 there. If I adjust this value over to here, it's equal to 0. Okay, so notice that when this slider is closest to the ground, it's equal to 0, and when it's closest to the 5 volts, it's equal to 1023. If I were to switch these two wires, that would change the direction. Okay, so I actually kind of, I think, do want to change the direction here. I'm going to say that I want that to be equal to 1023 and this to be equal to 0. So to change that, pretty simple. I'm just going to connect my red over to here, and I'm going to come through with my ground wire and connect that to this side instead. Okay, now still when I'm towards ground, it's still equal to 0, but now when I turn it up towards 5 volts, it's equal to 1023. Okay, so that's my input. Now we can start working on our output. So let's call this servo output. And again, we can just leave that kind of blank up here. I'm going to lowercase at s because that's going to be the thing that changes in our map. So now in here, we're going to say, okay, servo, no, that's lowercase, servo output is set to a map. And so first thing we need is our input, which in this case is pot value. That's the thing that's actually changing. Pot value, the low end of the pot is 0, the high end of the pot is 1023. The low end of the servo is 0, the high end of the servo is 180. And let's say serial.print, and we're going to label this up here. Give me a moment. Okay. So at this point here, I've added these couple lines of code, right? It's just printing information. So serial.print, I say servo output just so that I have some sort of a label there. And then I serial print ln my serial output, which is the actual number, right? Remember, things in quotes are just going to label it. Things that are on, not in quotes, are going to go back to like the values that they're at. So when we start our simulation and start our serial monitor, we can start to see some of our information here. Okay, so we go from 0 to like 180. Okay, but it'd be a lot easier to read if both of these were on the same line. So I'm just going to come back real quick, get rid of the line after pot value. And now when we look at these, they print. Okay, so 1023 is equal to 180. 0 for our input is equal to 0 on our output. And like if we go, to about 50% of those things, or like 530-ish, which is a little past 50%, and our output is at 93, which again is a little past 50%. All right, and if we came down here to like 256-ish, that's about a quarter of the percentage, and again, a quarter of this percentage would be 45. So again, you can see the scaled ratio between these two things here. So now we need to simply control our servo. All right, so I'm going to stop my simulation here, and we can start working on our servo. So if we look back at last week's, remember when we do this, we're going to say our servo name, .write, but last week we put numbers in here. This week we're going to put the servo output integer in here so that it changes every time it goes through the loop. So example.write, okay, but instead of, again, a 0 through 180 here, we're going to say servo output, which goes from 0 to 180 ultimately, but it's based upon the input. So now when we go here, we can start to see like the servo right now is trying to move into position. When we adjust this here, notice that the servo is also changing. It takes a moment for it to like catch up. We come to the next one here, and it will start to shift around. And then all the way over, right? So that's 180 degrees. And when we flip this back to 0, the servo is going to turn. And again, this is taking a while because the code is like running really slow. It thinks that only about 4 seconds has passed since I've turned this thing on, even though that is completely wrong. But you can see how like here, that's there. If we watch this go back to 180, we're going to see this horn, which is what these like controls are called. They're called servo horns. We're going to see this horn flip around to about 180 degrees from where it was prior. Okay. So again, this week we're looking to be able to control our servo. We're looking to be able to read the input value and see it, print that out, and also print the scaled value that your servo is going to output. Okay. So that's it for this week. If you guys have any questions, feel free to email me. And happy coding. We'll talk to you soon. Bye-bye.